Now, because your final will be online, I still am going to have you write everything down because maybe they'll let you get partial points. That is one of the bad things, is they gave a ton of partial points before and now it's online. I know that if it was on paper, you'd want to write everything down, and that's really what I'm requiring. Every one of these problems has to have a curve, and then either a z-score work that goes with the table, or something like this. This would be the full amount of work. Picture, calculator with labels, lower bound, upper bound, mean, and standard deviation. Pretend that you can read that. And the answer. Okay? That's the amount of work that I'm looking for. So here we go. Interquartile range is between Q2 or Q1 and Q3 subtracted. So we could find the z-score for 0.75 and 0.25 and then subtract the two. But I'm going to use the calculator instead. So what I have right here was, if I found the z-score, I would have gotten these two values. And one way to get the z-score, you don't actually have to write this down, would be to do inverse norm. Inverse norm 0.25, comma 0, comma 1. If you have a 0 and 1 in here, it's going to give you the z-score because it has normalized the curve, right? So that would give you the z-score. But we don't really care about that. What we'd want instead is, what is the cutoff where 25% of the curve is below it, right? 1/4 is 25, 2/4 would be 50 cents, 3/4, 75 cents. So I would actually just do inverse norm. This would be helpful if I was going to use the table. Inverse norm 0.25 with a mean of 550 and a standard deviation of 12. And if you did that, it would give you this 541.91. And then you would do it a second time, putting 0.75 in, and it would give you this value. So we know 25% of the bags of M&Ms have 542 M&Ms or less, basically, and 75% of the bags of M&Ms have 558 M&Ms or less. Well, what's the interquartile range? Quartile range is Q3 minus Q1, or 16.19 M&Ms. Okay. Something that I don't know if it still shows up because nobody's asked me about this. I just noticed it today. If I said the z of 0.25, that's saying give me the z-score that is behind, that 25% of the stuff is behind. So this z-score right here is the z of 0.25. Notice that I didn't put the negative. I don't know, maybe I left that off, but that's what they're looking for. Okay, so let's do a different problem. If a company wants to guarantee that no more than 5% of the bags have fewer than 540 M&Ms, what mean should they try? So basically they have a machine that you can set it to, I want this many M&Ms. And they know that it tends to deviate by about 12 for a standard deviation. Well, they don't want to have so few M&Ms that people complain. So they're saying this, okay, what value should I set my average to if my mean, if I want my cutoff for less than 5% to be 540? So this time I know my value, I know my standard deviation, but I don't actually know what the mean is because they're going to change the way they've got the machine set up. So what I do know though is I know the relationship between 5%, the mean of 0, and we know the standard deviation. So basically what we're going to do is say, what is the z-score for the value that 5% of the data is behind? So in this case, I would actually do inverse norm 0.050, comma 1, and it would look like this if they asked you for it in the homework, z of 5%. And it turns out that this 540 is 1.644 standard deviations below average. Okay, so now you want to know what the mean is. Well, we know our standard deviations are 12, so you could add 12 to it, plus 64% of 12, and you would figure out what the average is. Or we're going to use our formula. We know 540 has a z-score of negative 1.644 in this population, given the standard deviation is 12. We want to solve for the mean that made that happen. So you just do algebra. Okay, so it's multiply both sides by 12 to get rid of the denominator. Okay, and so whatever this is, you'd get 12 times that would be some number, equals 540 minus the average, minus 540 from both sides, and you'd get a new number, equals negative the average, and probably be a negative number. So then the average would be whatever that is. I didn't feel like doing it. 559.7. So if they set their machine at basically 560 instead of 550, then they're going to assure that less than 5% of the bags have 540 M&Ms or fewer. Questions on that? Okay. Again, there's my z-score formula. We could do the exact same thing if they were trying to solve for the standard deviation, but we knew the average. I'm not going to show you 9. So that just kind of reviews what we did before. The only thing we have left is to talk about a formula that they give you. I don't know if it's in the reading or if it's in the homework, I can't remember, but let's go over it. This is actually notes right from the college from one of their professors. So it's going to be a quick review. It reminds you, we have X distributed normally with a mean of mu and a standard deviation of sigma. It looks something like this. This was on your day 1 notes. We know that 68% lie between here and here, 95 between here and here, 99.7 between here and here, right? And it says, hey, if we wanted to standardize that, make the mean 0 and the standard deviation 1, it would look like this, and now we call it a z-curve. Okay. And it says, for any x value, there's a corresponding z-value we will call the z-score or the standard score. Again, I'm reviewing based off of their notes. Okay, and we could use this z-score. This is the score that this is the formula you've been using all along. Okay, well, here's the deal. Just like with the finance unit, remember how they'd say, here's the amortization formula, or not the amortization formula, here's the add-on annuity formula. Now here's a new formula if you want to solve for D. I don't want to have 2 formulas, okay? So they're saying if you wanted to solve for X, like we did up here, where we used algebra to solve for it, you could actually legitimately solve for X using the formula, and that would be your new formula. Like multiply both sides by the standard deviation, so you'd get this, and then add mu to both sides, and this would be your formula if we rewrote it and solved for X. So they're both the same formula. This one where Z is solved for, and this one where X is solved for. I really don't ever use the second one because I don't want to have to remember 2 formulas. I can do algebra, but I don't remember why, but apparently when I made these notes, it was necessary. Okay, so here's an example straight from the college. A doctor measuring serum HDL found a mean of, and I changed it to 63.8, and a standard deviation of 2.5. Find X, find the cholesterol that has a z-score of negative 0.85. So we're solving for X. So we could use our old z-score formula, right, like we just did, or we could plug it into their new formula. Either way, you would get the same answer. So if you want a new formula, there you go. And again, all this is here is the picture showing what we're saying. We're saying we have a z-score that's negative 0.85 below 0. And we want to know what this value is, so we solve for it, and it's 61.675. Okay, now it says find z if the value is 70.1. So find a z-score. Basically, this one is an example of when to use the x formula if you want, and this is an example of when to use the regular formula. Okay, so from the empirical rule, what we know about normal curves, would a z-score, or would a cholesterol of 61.68 surprise you? Okay, if somebody came home and said, hey, I got back from the doctors and my HDL was 61.68, would you be like, oh my gosh, that is so low? Or, oh my gosh, that is so high? No, right? 61.68, which is basically this one, is not even one standard deviation below average. It's right where it should be. It's typical. Okay? No. However, what about 70.1? Yeah, that's high. That is almost 3 standard deviations above average. If you took the average and added the standard deviation, that's almost 3 standard deviations above average. It's pretty rare. It's getting high. You might need to change your diet. Okay, my husband came home with that, and I would take away his steak. Actually, he did, and I failed to take away his steak, but that's okay. I lost. And that's it. So I didn't do this for the other class, but I'm going to kind of summarize this unit. You need to know, and it is on Canvas, it's always there. You need to know the empirical rule, right? The 68, 95, 99.7. You need to know how to use the z-score formula. You need to know how to find the probability or proportion or area under the curve. They all are the same thing given a cutoff value, i.e. using normal CDF, or you need to find the cutoff value given the area under the curve. So that'd be number 2, this would be number 3, inverse norm. That really sums it up. Like, I could teach this unit in 45 minutes, but you wouldn't have the background, and the background will help you next semester. Plus, they want you to know both ways, or I would have skipped it. Okay? So you have the rest of class, over an hour, to work and ask me questions because I think you need it. Good luck. And again, all of this is on the front of every unit.